So today on the lightboard we're going to be looking at spontaneous reactions. So we've got our example here that was in the lecture, and there's two ways that you can work out whether a reaction is spontaneous or not. You can work out the delta S of the universe, and if that is a positive value, it's spontaneous. If it's a negative value, then it'll be non-spontaneous. Or you can work out the delta G, and if the delta G is negative, then it would be a spontaneous reaction. So what I've done is I've looked up the appendix and I've written down the delta H values for each of the compounds and the delta S values of each of the compounds. So it's really important to remember to check the units when you do these types of questions. So you can see that delta H I've written kilojoules and delta S is in joules. So when you put them together in the delta G reaction equation, you'll need to change them so that they're in the same units. So that might be in kilojoules or it might be in joules. So to work out the delta G, we can do delta G first. Delta G equals delta H minus T delta S. Okay, so we need to work out our delta H for the reaction and our delta S for the reaction. So let's start there. So delta H equals your products minus your reactants. So it's the same thing for your delta S. You can also do it for your delta Gs, depending on the information that you're given. So let's look at our products. So we've got NO2 and H2O as our products. We've got 4 NO2 molecules, so we need to multiply our value for NO2 by the number 4. Okay, so that's that one. And then water is minus 285.83, and we've got 6 of those. Okay, so that's our products. Now I'll write our reactants down the bottom, so this is split over 2 lines. So we've got 4 times minus 46.19 plus 7 times 0. Okay, so that's our products minus our reactants. So if I put that together, plus minus 285.83. Hang on, I've got to do that in separate sections. Okay, so if we add those and multiply those, we get 1,579, and then we get minus 184.76. So remember, minus becomes a plus, so you end up with 1,394.86 kilojoules. Okay, so this is just plain kilojoules. It's not kilojoules per mole. We've taken into account the stoichiometric relationship of the reaction when we've calculated delta H. So now if we calculate our delta S, again, products minus reactants, but now we're using our delta S values. We've got 4 times 240.45 plus 6 times 69.91. Okay, and again, I'll split it over 2 lines here. So we've got 4 times 192.5 plus 7 times 205. Okay, so if we add those, we get 1,381.26, we get 2,205. So if we, yep, they're all positive values. So if we add or subtract that from the initial one, so we get 1,381.26 minus 2,205, we get minus 823.74 joules. Okay, so I'm going to write those values here. Okay, so delta S comes out at 823.74 joules, and delta H comes out at 1394.86 kilojoules. Now what we're going to do is put these values into our delta G reaction. Okay, so now we've got our delta S, which is minus 823 joules, and we've got our delta H, which is minus 1,394 kilojoules. So in order to put the delta S and the delta H into our delta G, I need to convert this into kilojoules. So remember, dividing it by 1,000, or 3 jumps, puts you into kilojoules. So we get negative 0.82374 kilojoules. Okay, so now I've got my values. My temperature is 25 degrees Celsius plus 273 to get me into 298 Kelvin. So the temperature is always in Kelvin. So if I write that out again with the values in there, so then it's just a matter of putting it in your calculator. So when you're working it out, work out this section as a whole. Okay, so I've got my minus there, so put that guy back in there. So I've got 298 times negative 0.82374. Okay, so that's 1394.86 minus 245.47. Let's go 7. Okay, so minus is a plus, so I've got minus 1394.86 plus 245.47. So that gives me minus 1149.39. And this is in kilojoules. Okay, so that's how we work out our delta G. And we've got a negative value here. So remember, if delta G is negative, then it is spontaneous. So this one would be spontaneous. Okay, so I'll show you quickly just how to do the delta S of the universe while we've got this question up. So that's our delta G, so delta S of the universe, the equation there, equals delta S. So delta S of the universe equals delta S of the system, which is the delta S that we worked out down here, plus delta S of the surroundings. And the formula for delta S of the surroundings equals minus delta H on T. Okay, so we've got our delta H value, we've got our T value, we can work that one out. So we've got, we can do delta S, sorry, having trouble with such a small space. Okay, so we'll do delta S of the universe. So if I put in my systems and surroundings, let me firstly work out my surroundings. So it's minus delta H. Okay, so my delta H on T. So putting that one into my calculator now. So I've got 1394.86 divided by 298. Gives me 4.68 kilojoules. So then I can put that into my delta S of the universe. So I've got 4.68 plus 0.8. Let's round that up to, let's just leave that at 2. And we've got a negative value there. Okay, so that one gives you plus minus 0.82, gives me 3.86 kilojoules for the universe. Okay, so that's my delta S of the universe. So you can see again we've got a positive value indicating it's a spontaneous reaction. Okay, so to work out if a reaction is spontaneous or not, you can look at the delta S of the universe, or you can look at the delta G. So delta S of the universe needs to be a positive value and delta G needs to be a negative value. So key things to watch out for are calculation errors. So just using your calculator, if you have time at the end of your exam, just go through and check that you've got the right values there. And the other thing is unit conversions. So you need to make sure that your delta S is in kilojoules for you to put it into the delta G, or even just the delta S of the universe equations. Okay, so thank you very much and good luck with this topic.